Hello everyone. In theories of meaning, today we'll be focusing on the truth conditions theory of meaning, which is abbreviated as TTM. So before the truth condition theory of meaning, if you want to know other theories of meaning, so already I explained in my previous lecture, that was the theory UTM, the use theory of meaning I discussed, and I also discussed the intentional theory of meaning ITM. I also discuss referential theory of meaning, right? And the referential theory of meaning, I also discussed behaviorist theory of meaning, right? And I also discussed ideational semantic or ideational theory of meaning. So I guess so far I delivered 3 lectures. So this will be part 4 lecture that will be focusing on the theories of meaning. And in today's lecture, our focus will be on the truth condition theory of meaning. Let's begin and learn what is the truth condition theory of meaning. The truth condition theory of meaning, which is abbreviated as TTM, emerged in response to objections against the referential theory of meaning. So this theory came, right, in response of referential theory, or they objected the referential theory that meaning of theory do not exist in the real world, as referential theory says. Fine. So RTM, referential theory of meaning, and the need to connect language with the physical world, right? Referential theory was doing what? They were connecting language to the physical world, the things which existed in the real world. So Tarski was one of the first modern thinkers to lay the groundwork for TTM in his work. Let's discuss in detail. Understanding sentences through truth. So they say that the central idea of TTM is that to understand a sentence, you need to know what condition would make it true or false. That's important. If you're saying something, you have to see that what are the condition, whatever you are saying, that is true or false. So जो भी आप कहते हैं, so जो आप कहते हैं, तो उसके लिए कुछ conditions होंगे. वो condition आपके statement को verify करेंगे कि आया जो आप कह रहे हैं वो true है कि true नहीं है. So, what condition would make it true or false? As Wendell put it, that to understand a sentence, to know what state of affair would make it true or false. वो कौन से state of affair, कौन से मामलात होंगे जो आप कह रहे हैं, तो आपके statement को वो true या false declare करेंगे. For example, the sentence, the cat is on the mat. This is a sentence. Is true if and only the cat is indeed on the mat. So जो आप कह रहे हैं कि आप, for example, a speaker says cat is on the mat. So ये तब तक true नहीं होगा जब तक cat वाकई mat पर ना हो. So in order to prove that this statement is true, you need to do what? You need that is true if and only if the cat is indeed on the mat. So आप truth condition देखेंगे कि वाकई cat है, वो मैट पे है कि नहीं है. अगर वो वहां पर है, this sentence is true. अगर वो नहीं है, तो this sentence is false. This is okay what TTM says. Tarski definition of truth. Tarski introduced a formula to define a truth in a deductive system, expressed as follow: N is true if and only if S. So N is the name of a sentence and S is a sentence. So here S represents any sentence. S represents any sentence and N is the name of the sentence. For instance, the statement the sky is blue is the name of the sentence. Is true if and only if the sky is in fact blue. If you say that the sky is blue, so you'll have to look it up. आप ऊपर देखेंगे. अगर वाकई sky blue है, तो तब जो है ना आपका जो statement है, जुमला है, वो true consider होगा. Now, Davidson's contribution. Davidson later adopted Tarski's idea for natural languages. He suggested that for every utterance of a sentence, we can express truth condition as an utterance of a sentence S by speaker X at time T is true if and only if. For example, this means that understanding a language involves knowing how to specify the condition that makes sentence true. आप कंडीशन को भी आइडेंटिफाई करेंगे कि कैसे वो सेंटेंस को ट्रू साबित करता है. फॉर एग्जाम्पल दैट फॉर द सेंटेंस ऑल ह्यूमन आर मोर्टल, so we can express its logical term as XH and MX, where H stand for the human and M stand for the mortal. So if humans are there, then they are mortal. If humans are true, then their mortality will be also true. Truth condition in practice. So what is truth condition in practice? To find the truth condition of this statement, we identify that HX is equal to or leads to MX, which read as if X is human, then X is mortal. Holds true. We conclude that this statement is true if the logical implication is true, which can be verified using truth tables. So if you are human, then you will be mortal. So you can only be mortal if you are a human being, and it can be verified in truth condition in the world. Now, strength of TTM truth condition meaning. TTM is seen as both plausible and powerful. Its plausibility lies in the fact that understanding a language means being able to determine the truth condition of unfamiliar sentences, right? You have to verify. As Richards notes, when a person can listen to a sentence in that language and figure out that the condition under which they are true, we grant him or her good understanding of language. अगर वो आप कोई बंदा जुमला कहता है और वो गलत होता है, तो आप कैसे समझेंगे? सो पहले आप उसको वेरीफाई करेंगे कि कौन से कंडीशन है जिसके उसका जो सेंटेंस है, स्टेटमेंट है, वो ट्रूथ करार दिया जाता है. तब भी जो है ना आप लैंग्वेज को समझ भी सकते हैं. So the power of truth condition meaning come from its foundation in classical logic, which can easily be applied in computational contexts, right? Now, criticism of truth condition meaning. However, truth condition faces significant challenges, as the key objection is that while factual statement can be true or false, other type of utterances such as promises, orders and prayers cannot be easily assessed in terms of truth. ठीक है, आप कुछ जुमलों को ट्रू कंसिडर कर सकते हैं, राइट? और वो जुमले आप ट्रूथ कंसिडर कर सकते हैं जो फैक्ट पर बेस है. फॉर एग्जांपल, आप कहते हैं कि दिस इज अ ट्री. In order to verify, you will have to see it's a tree or not. Or if you say, okay, that this is a black color, right? The color of mobile is black. आप इसको वेरीफाई करेंगे क्योंकि वो फैक्ट पर बेस करती है. और अगर आप कहते कि टुडे इज फॉर एग्जाम्पल सैटरडे, आप उसको वेरीफाई करेंगे कि सैटरडे है कि नहीं है. सो वो जुमले जो ट्रूथ पर बेस करते हैं तो आप उसको वेरीफाई तो कर सकते हैं, लेकिन वो जुमले जो ट्रूथ पर बेस ही नहीं करते हैं, फॉर एग्जांपल प्रॉमिसेस, ऑर्डर एंड प्रेयर्स, आप उसको वेरीफाई नहीं कर सकते, right, in terms of truth. So what about them? So the limitation questions the applicability of TTM in all form of communication. तो फिर आप TTM को तमाम form of communication में use नहीं कर सकते. It's good, right, that you verify whether somebody is saying something is truth or false. But it is possible only for those statements, right, which are considered or which deal with the truth, with the facts. But what about those which do not deal with the fact? For example, if you say, okay, that I like this, so like I like this, it cannot be assessed. क्या अब ये सच है कि नहीं है? क्योंकि आप इंसान के अंदर कैसे जाएंगे, देखेंगे कि वाकई उसको कुछ पसंद है कि नहीं है, क्योंकि ये फैक्ट पर बेस ही नहीं करती. सो इसलिए इसमें ये फिर प्रॉब्लम आ जाती है. तो ये वी कैन नॉट अप्लाई दिस इन ऑल सर्कमस्टांसेस. So conclusion in summary, TTM offer a compelling framework for understanding meaning through the truth condition, but it also raises important questions about the nature of different type of language and meaning. Now we have the last theory of meaning, and that is known as AI theory of meaning, right? So, procedural semantics. Starting the early 1970s, research in artificial intelligence. So AI stands for artificial intelligence, and it's very much active these days in all kind of application, all kind of platform. Okay, artificial intelligence sought to develop a theory of meaning based on the insight from the field itself, and a movement now known as procedural semantics or procedural theory of meaning. The ideal robot. To explain procedural semantics, consider the concept of an ideal robot. This robot, represented as universal Turing's machine, is equipped with sensors and factors which allow it to recognize various actions. Unlike a regular computer, so the robot's internal state is richer, enabling it to represent the relationship between symbol and their reference. For example, while a computer might store the word apple as an data, the ideal robot can have a more comprehensive internal representation that includes sensory experiences related to the actual apple. Right? Now, meaning defined through state and procedure. In procedural semantic, meaning can be defined in relation to the robot's internal state S or its program's procedure P. This leads to three forms of expressing meaning. For example, that you can see here is a formula. So, of these, form B, which define meaning through procedures, has received the most attention. Now, here we can see that Johnson-Laird's contributions. The primary advocate for this approach is Johnson-Laird. He introduced a compile-execute dichotomy, suggesting that when an utterance UUU is made, it is first compiled into procedural form within the brain, akin to machine-level language, and then executed. This execution of these procedures represents the semantic interpretation of these utterances. According to the Johnson-Laird, the intention of the word, their meaning in context, is identified with the procedure during execution, while the extension of the actual entities the word referred to results from these procedures. For example, the command pick up a big red block ultimately translated to call the pick up program. Advantage of procedural semantics. One of the key advantages of procedural semantics is ability to incorporate contextual information. As Ringels state, apart from context, words have no meaning. So this theory emphasizes that understanding meaning requires considering how humans perceive the use context in communication. Criticism of procedural semantics. Despite its strengths, procedural semantics faces a significant criticism. A major objection is that not all sentences or utterances can be executed as a procedure. For instance, consider the question, is Fermat's Lesson's theorems true? Even though this question has not been definitely answered, it still holds meaning and cannot be easily dismissed as executable. Conclusion. In summary, procedural semantics offers a dynamic and context-rich approach to understanding meaning in language. However, it is also encounters challenges, particularly regarding the nature of non-executable sentences. So thank you so much. It was all about these two theories we discussed. That was AI theory. Perhaps AI theory we will discuss in coming lecture in detail, because right now I got a little bit tired, so I couldn't explain AI theory in much detail. So keep watching and enjoy learning. We discuss and discover with Dr. Imran. Thank you so much.